code and they were reviewing it. Thanks for your effort in getting them involved. But it looks like they're reviewing some of the previously completed API decisions, including resources. Let me just share the screen so we can look at it.
Hi, Vinay. I am here today. This is Tim.
Oh, hi, Tim. So, okay, can everyone see my screen?
Yes.
Okay, great. So yeah, Tim was asking whether we really need the resources allocated to be in the spec. Why not do local checkpointing, sub resources versus resources to set resources allocated instead of having the pod, the admission plugin that we added, the pod resource allocation plugin, and a few other questions around runtimes. I hope Mike Brown is here today. He could share some insight on the particular question is if a runtime class, whether it should be allowed to say, I can't do in-place resets. I think this arose out of a scenario where VM runtimes, they may be able to access CPU within the within the CPU, integral CPU bound. So if you're going from one CPU to 1.5, it can do it without restarting, but we might need to restart if it needs to go to 2 CPUs. So a situation like that, and in general, the way we have currently defined it is we are saying no restart is okay. As far as Kubernetes is concerned, we won't do anything to restart you, but for the end user, that may not be true, and that looks kind of like the user experience is not really well defined there. They might see something that's they might expect something and not happen, and that might confuse them, and they may not be happy about it. So
Vinay, can I say a couple words?
just going through the agenda for today, I think the main question we want to look at is
Sorry, can I
yeah, go ahead,
just say just because I don't want to waste anybody's time. So I jumped on this KEP because it's particularly interesting to me. I worked in Borg and Omega before inside Google. I know just how complicated this problem is. And actually it's more complicated than even I understand. So I'm very interested in it. Most of the concerns that I had, I think I've waived. I have only a few points left that I think are worth discussing. And specifically, that's the spec versus status, checkpointing versus API thing. Whether we want a sub-resource for resources, conditions and events and signals in general. And the last point is the sort of the semantic that you just described, though I like the words that you wrote on the KEP. So actually in my mind, that one's resolved. So I'm down to three standing points.
Okay. So let's pick up the first one. So we the reasons I mentioned, and I just responded to that. I think the benefits of having resources allocated in the spec is twofold. One is it opens the door for what seems like a useful feature where a pod can say, hey, I need, at minimum, I need like X amount of resources, say 1 CPU and 1 gig of RAM. Ideally, I'd like 2. And then we'd admit it at X, at 1, and then work towards 2 where possible. So that way the pod would get scheduled and start running with its minimum required, rather than not stay pending because resources are not available. So
that feels
is
really
one potential thing. The other one is
like
okay.
I can't think of how I would use that, and I don't want to design to hypotheticals. My main argument for context for anybody who hasn't read along this giant PR back and forth, like I admit there's a lot of comments going on there. The main point that I have with it is, as an API reviewer, I find it to be very weird to be putting something in spec that the owner of spec isn't allowed to write to. And the need for this admission control, which is using identities to subset who isn't allowed to write to certain fields, is really unprecedented, and is a strong smell to me that something isn't working right. So I asked why not status, and Vinay helpfully disavowed me of the idea that that would actually work. And you know, there's a nice corner case that I had missed in my head. What I really think though is, why should this be part of the public API as opposed to being effectively a kubelet problem? Um, uh, it feels to me like the right answer for this is a local checkpoint and to store the allocated in status. Um, that fits with all of the precedents around the API, both you know, the API spec and status blocks being owned by different entities and all the general patterns without needing any special cases. But it requires a kubelet checkpoint.
Hey Tim, this is Derek.
Hey, Derek.
So I want to apologize to Vinay because I know that this has been a topic that's gone on discussion for feels like a year now, and so I think your point on this being hard is valid. My memory on why resource allocated was needed was that it was to facilitate signaling when the kubelet had acted on the change. Like right now, I thought we have the issue of when you're resizing a pod, you have the initial resource requirements of that pod that were enumerated, and then you have a need to say, I want to bump that or decrease it, and we had no way to kind of express when we reached a level state. So like if you just had updated the resource requirements, then if the kubelet couldn't size you down, you were still using 4 more resources than you had initially claimed, and there could be some inconsistency. And so I thought it was that need to coordinate on, have we reached a level state, that needed to be understood by scheduling, quota, and node that led us to where we are. If my memory is incorrect, maybe that's a sign that our initial thoughts on it are not as,
Yeah, that's
Your
one of the
memory.
reasons I mentioned.
yeah.
Yes.
And so like to me, the sniff test, Tim, is like, if having not read this KEP in 6 months,
Mhm.
does the original rationale still hold, like that I could explain why we work how we work? I
So
thought
I think,
the clear issue is that if you just had local kubelet checkpointing, you had no way of knowing that was the resource reclaimed from a quota perspective, and did the scheduler understand the actual state of resources on that node?
right. So let me be a little bit clearer. I'm actually suggesting that you keep allocated, but you move it to status, which changes the corner case from I need to be able to signal that this thing happened to what happens if the node reboots and all of that information that's currently in memory is lost. And that's where the checkpoint comes in. That covers the corner case of what happens if kubelet loses its memory. Because you know, we don't have a representation of things like memory request in any durable place.
So I think the issue with that, and again, I'm happy to be wrong, was that at the time I thought we wanted status to be entirely reconstructible by the kubelet on a restart. And so if the kubelet reported status for what it actually observed was being used, that was not consistent with what was previously requested. And so you still had, say, the quota subsystem potentially being gamed or confused because it would not be aware of an attempt to reclaim resources. So I thought quota is updated to look at allocations. And so just quota wouldn't be status aware. And so that was one of the other design tensions.
Yeah, I think quota has to be aware of status in any case, because it has to take the larger of the request or the actual, right? Because on a shrink, like this is the attack that Jordan laid out, right? I could schedule a pod that requests a gigabyte of memory, and then once it's accepted to a node, reschedule it to use 1 byte of memory or 1 megabyte of memory. And my quota would say I'm using 1 megabyte when in fact I was using 1 gigabyte. because kubelet wouldn't be able to shrink me because I had active pages or something.
Yeah. So I agree. It
and-
always used to take the max. I think that's what was in the cap at the beginning. I think that there's like two tensions though. Like if it only looked at the max. All right, let me think on that one a second. I'm trying to think through why.
Can
this
I
was
chime
always
in real
at the
quick?
time. Yeah, go ahead, David.
So we actually don't need to use the max. The reason being that there are two kinds of changes we could make. We could either change the requests or we can change the limits. For limits, that can be rejected if, for example, you're using all of your memory. But the downsizing for requests will always be accepted by the kubelet. So we don't actually need to use the max. You can temporarily, for example, downsize your quota, but that should immediately or very quickly take effect.
As long as your limit is larger than your request, right?
That is interesting
it-
validation.
I'm trying to understand what David means. If I have a guaranteed class where limit equals request, then a shrink would be shrinking both, right?
Right, because we said that you are not allowed to change quas tier.
Right. Which is also an interesting attack, right? I could get a guaranteed class pod that I then shrink request on, or like, are we going to enforce that if you're in guaranteed class, you have to shrink them in sync?
I believe the current behavior as proposed and implemented would actually, you would accept the change in requests and that would take effect immediately. So if you had eviction, you would actually evict based on the new smaller requests, but the limits would, the kubelet would attempt to reduce the limits after the new spec has been accepted with quotes,
Right.
and that could be rejected.
So would it be possible if I schedule my pod for a gig of memory, request equals limit, I get guaranteed class and all the benefits that go with that, and then I come in and I change my request to 0?
So in that case, well, I don't know if you can be guaranteed with a request of 0. You could change your request to 1 kilobyte of memory, right?
just finished season 5.
In that case, you would actually be, you could very well be evicted there because your actual usage would be exceeding your requests, and that's the primary mechanism we use in eviction ranking.
But I would still have a priority over things that started in a lower quas class, right?
No.
Isn't
Quas
there
is not
some
directly taken into account during eviction.
All right. It's interesting. It wasn't where I was going with this in the first place.
I think pod validation though, again, my memory is weaker here. I thought in pod validation, we actually verify that you can't change the quas class of a pod when making the update itself. So
Yes.
I think
Yes.
David, eviction's kind of a second order effect, but like, I'm not aware of any reason, unless I'm mistaken, that you could change quas classes with the current proposal.
Right. Yeah, I'm
Right.
not suggesting you can change quas classes. I'm suggesting that there are 2 steps to a resize. One is admission by the kubelet, where it admits the resize, and one is, say, actually adjusting C group values by the container runtime. If you have a resize that is admittable, such as a downsize of a guaranteed pod, but is not updatable by the runtime, you can end up after admission where your requests and limits have been changed according to the kubelet and according to its record in memory of that pod, but have not been changed as far as C group files. And all I'm saying is that because eviction is based on the admitted requests and is compared to the actual usage, that you would sort of be in a weird state where you could be evicted as a guaranteed pod if the resize isn't possible. But what I am saying is that the important thing is that the admission would never be rejected at admission time, right, of a guaranteed pod being downsized. But you could have a state where it was unable to reduce the actual limit of the container because that memory is in use.
Yeah, this is why this KEP is so much fun.
Yep.
So the question here is, the way it was explained to me, Vinay helpfully explained this corner case of having 2 pods, and if kubelet were to restart, it would not know what its previous decisions had been, right? If, for example, status got lost, right? Which is always sort of the litmus test for status, right? What if I erased it, would it come back? That seems like a real corner case, but can be worked around by having kubelet acknowledge its own previous decisions via a checkpoint, right? Like I have admitted this and I have decided it made sense. In the case of a restart, either I have the checkpoint, in which case I can resume where I left off, or I don't have the checkpoint, in which case I hadn't really made the decision yet. And that seems okay, but it comes at the cost of making this facet a kubelet problem instead of an API server problem.
I still think there's a use case I'm missing that was clear at the time, and so where checkpointing alone is insufficient because
Derek, if I remember
the
correctly,
behavior can be a bit. Go ahead, Dawn. I'm sorry. I'm still.
so I just want to follow up to reply to you. What's the clear use cases? Clear use cases, it is what Vinay earlier explained. Because when we first talked to auto-scaling, the SIG auto-scale, whatever team, and one of the requirement it is the scheduler and the controller, and they want to initially really aggressively to set their allocated, to update, to adjust of this one. But then we'll base the historic data and adjust, and based on real usage to adjust. So they basically want to leave Kubernetes, make tons of the decision, but they want to, we give more signal back. And so they could just like the, maybe like the retreat back or maybe adjust. So that's the main reason originally. And we think about this, basically they want to keep a tab, describe what their desired state at a given time, but it's us, but it's not a user. So basically it is like the request, there's the one, it is from the initial user to send that request, set the initial request. And then there's the, like the system automatic adjust to us, that's all the spec. That's kind of the, I believe that's the original reason we think about it, because originally we also talk about status, but the status is not all those controller watch, and so they basically watch off the spec, and also that time there's the sub resource also have the limitation. So all those kind of things adds up together. So at least if I remember correctly, this is the one of the reason.
Like I'm imagining a thermometer, right? Where it's like, I originally set my temperature at X degrees. I am now asking that between the hours of 12 and 4, I want to dial my temperature up a little higher. And I thought that there were multiple values we wanted to read. One was what you were saying was, did the VPA ask for too high of a temperature that the kubelet itself couldn't satisfy? The kubelet still wanted to say what the current temperature reading was. And I thought there was some desire to kind of like find a way of approaching when we got to a level between what was desired, what was met, and how strong of a desire was being made. Maybe that made sense at the time, and that's not coming clear to Tim. But
I think I understand. I think I understand the desire for the signal. The problem that I'm having with it is really from an API consistency point of view. What you're describing as allocated here doesn't belong in spec. It is state information that isn't safe for the owner of a pod to set on their own, right? And that's the smell. If you look at other APIs that follow similar patterns, like service, right? The user can set their cluster IP, and we will respect their cluster IP if they set it. We don't have any case where the user is not allowed to set a field, but the field exists in spec. The
We
user is not
do,
allowed
right?
to set
So node name was the other field, right? So I
Yeah.
feel like that sniff test is the same sniff test that made me feel a horrible stench and probably delayed Vinay a lot. But then like we do have that, right? Like podspec.node name is not a normal
Node name is respected though. If you set node name, the scheduler will respect it and ignore your pod, right?
Yeah, it's the same here too. In fact, for the live API review with Jordan Leggett and KubeCon Contributor Summit, San Diego, that was the first slide I think I had where we're proposing this. The precedent for this is a node name, and we had resources allocated plus a sub resource for setting this from the node, and the precedent was binding and scheduler setting the node name.
So there's a difference though, because node name is immutable after being set. Right?
It's the same thing here.
And I thought you said node allocated can be set by kubelet at runtime whenever it takes a resize, or the resource is allocated.
Yes, only, not the user. So the node.
But that's the point. Is it is mutable by somebody and it exists in spec. We have no precedent for that. If something is in spec and it is mutable at all, it's the users. They own it. Whoever created the pod. If you don't want it to be mutable by the user, if it's not safe, like in this case, then it shouldn't be in spec.
The binding endpoint does, if you call it again, it's not that it's called, I think my connection is going on bad. So the binding node name plus binding, scheduler sets that once it sees that it's clear, and if it is not, if it's already set, then the scheduler will ignore it, and then it's the user scheduling the pod to a particular node. We know that.
But you can't reset node name. You can't come in through and
I'm
the
kind
user
of
cannot.
Is that a meaningful distinction, right? Like we have many actors that act on things in a system. Is the distinction you're raising meaningful? Like I can change the container image name on a running pod. Like, I guess what makes that distinction meaningful?
Yeah. The distinction is that there's a sort of philosophy behind the API. Like the spec is what you intend to be happening, and the status is what the system is actuating. And if you say there's a thing that exists in spec and I'm going to write to it, but you're not allowed to write to it, even though you own the rest of spec, you're sort of flying in the face of all of the existing conventions. And node name is different because you can't change node name. That doesn't cause a reschedule. That's not a thing. If you look at something like, I'm trying to come up with a good example.
So I guess
well, I'll go back to service, right? Like,
do you want schedulers to be status aware?
I don't see why that's a problem. It's not like it's not like it changes the watch behavior. When you get a watch, you get both spec and status.
So like if a pod has never been started or it's just stuck waiting to get started after it's been bound to a node, and the kubelet doesn't report a status on it, or doesn't report a resource allocation on it because a volume hasn't yet attached, and the containers were never actually invoked, like, do we want to worry about those things or not? I guess I'm trying to think through, like, when does the kubelet say that this resource is now allocated? And then the kubelet still has to report what actual observed usage is, right? So the requirements section and the status section would always be 99% of the time in sync. And then the kubelet needs to report when it's updating status. In some cases, like memory, it wants to drive that down incrementally because it can't do it in all one fell swoop.
Right.
So I'm wondering, like, how many writes back to status at what frequency would we be doing, and other knockoff effects that my brain isn't able to follow right now. But the The other alternative, I think, when we
Totally.
discussed this, Tim, was that we talked about having a secondary resource that you could write to, but then that had challenges as well, because the scheduler would have to be
Yes.
reading that additional resource, and the kubelet would have to be watching that additional resource, and it had scaling impacts.
Yep. So I concur with all of your assessment. This is not, there's no obviously easy, good answer. Given, I think actually all the work that's gone into the CAP is really good. What I'm trying to offer is what I hope, and I'm hoping there's no corner cases that I missed, I hope is a slightly surgical modification. I'm saying take allocated with the semantics that you've currently assigned it, move it to spec, or move it to status, and anybody who's looking at a pod needs to consider sort of the tuple of requested, allocated, and actual, and make decisions that are sort of context dependent based on those three fields. You can't just look at any one. And to cover the case of, well, what happens if kubelet restarts? Kubelet has to save that information. It has to save its own decisions somewhere, and the API is not the right place for that unless it's part of the specification, and I guess that's it. Sorry, I'm thinking out loud as I'm chewing on your arguments too.
I don't want to portray my arguments as being stronger than my memory allows me to have. So on the checkpointing side, I know we've been bit by checkpointing the kubelet, so there would be some polling, at least on a CRI, to see what's possible there. Empty dir volume usage is actually really hard to measure appropriate in status. And so that's a little tricky.
I don't think we actually need to measure empty dir usage. We just need to measure whatever limits we've placed on it, which I think is just static today. Or they're not actually enforced by the runtime.
If you're reporting the usage on a per container basis, which is what I thought we were doing here, and multiple containers can write to that empty dir, then your usage reporting, I forget how that gets tracked. I have to check, David.
It's not actually usage that we're adding to anything.
We only need a checkpoint of the like the Kubernetes decision, like the second of Kubernetes adjust of decided. It basically is kind of the secondary. And there's like the first, it is like the cluster level admission, and then down to the Kubernetes, and then Kubernetes actually checkpoint the current they are working upon. So it's not real usage here. I definitely don't want to checkpoint the usage. And I think I repeat many times. And because the usage, first thing, if the pod is not die, container is not die, and the usage can be recovered. And the second, once you checkpoint the usage, and there have a lot of known issues we talked about in the past.
You're right. I apologize for usage. It is just needing to introspect what the runtime had been previously told to write in SIG-profess.
So I initially thought, oh, well, it's because C groups is missing information, but actually I don't think that's sufficient either, because there's still a case of what if the node rebooted and came back and you just want to restart all your pods in place? All the C group information is going to be lost. So I think this is a case of kubelet is making a decision and it needs to remember that decision over time.
Right. This is we just need to record the admission decision. We are essentially admitting resizes, and we need to record what we previously admitted.
Which is why status wasn't perfect for that, right?
That's right. That's why you need some sort of local checkpoint, because that doesn't pass the status test.
No, but like it's been admitted to the API server now, right? Like, and so now we're bringing this into the kubelet, and the kubelet has to be like, yeah, I can still fit this, or I can still grow this. And so like the scheduler hasn't even been involved in the regrowing of the requests, right? They're not there. And so it's the node fit check and
Right.
So
Tim, there was another aspect to this. We were looking at scheduler potentially assisting a resize. Like let's say it's a high priority pod, and then the scheduler notices that the same argument that I have for VPA here, where it can keep a running average of what the expected time for this to be updated once it sees the resources change. Scheduler can watch that same metric and then say, hey, this has been, it typically, if the kubelet could resize it, it takes like 2 seconds and it's been 5. Maybe I need to kick out some lower priority pods so to help this guy grow.
So I
So
love that
that's
idea.
another, it was part of this. We scoped it out for keeping the footprint of the code changes. It was getting too complex, and
Yes,
it's already pretty complex.
I love that idea, but I think that's like step 2 or 3, maybe 4.
Yeah, it's part of it's part as a few enhancement. It's something that was considered for the skip, but it would be behemoth with that.
Yes. So my main argument here again is looking at this purely from an API reviewer point of view. This feels wrong. It feels like you're using spec as the checkpoint that you don't have.
so here's a question, Tim. I'm sorry, and I'm getting my thoughts back into my cache. So I got a kubelet with a pod restart policy of always, right? And it's been bound to node Derek, and the Derek node has very few resources because he's just too strapped, and so he's got 3 CPUs, a gig of memory or something, and the pod fit there just fine. It requested 1 CPU and a gig of memory. And then Tim comes in and says, I want to grow that pod to be way more resources than the Derek node has. Now the Derek node had been running this pod, let's say, and the pod had died, and then it needs to be restarted. It can no longer ever actually restart to your new size request, which to you as Tim is the bad outcome, which is what I thought we were trying to achieve with the allocated flow. Like, it's just going to be, you scheduled me to a node that can't fit me, and I'm still on this node that can't fit me, and you let me be resized higher than the node that can't fit me. And the kubelet's never going to go and rerun your workload at the lower resource level that you originally requested. So you basically now are in an outage. And so I feel like the orchestration we have between the 3 values rather than 2 values prevents an outage, because I could still keep running you at the lower value. And I'm now not able to run you at all.
No, I think with the checkpoint, what you described is exactly the good path of what you described is what we will have. Allocated is still present, and it's there in the checkpoint. That's what kubelet has put aside for you. And the
checkpoint
actual
beyond pod status, you're saying then?
Well, yes. I mean, the field is published through pod status, but kubelet has a file on disk or something that says this is what I decided in the past. So in case status were to go away, I can always redecide that. And the pod would be able to restart with the lower limit, and kubelet would have a way to say, hey, this resize request, while formally, schematically, it is correct, practically, I will never be able to do it. And that's what we want, right?
Yeah.
Okay, I have to watch the time, and here we already spent like roughly of the 40 minutes on this one.
Holy moly.
And so I think we've been back and forth talk about this one for more than a year.
Yeah.
And the team, thanks for you raise all the concerns and refresh me a lot of memory, and I believe Derek too. So we can carry on this one more, and please, like the community and everyone, if you are interested in topic, please take a look. This is like the really good chance to revisit our decision. And I think about, we also lead the loop of the auto scaling team here, because a lot of the requirement and I think team, you understand a lot of like the auto scaling in Borg and what's the pinpoint. I understand what you propose, the checkpoint, all those kind of things, try to also prevent those problems. And because obviously we use the checkpoint of the usage, make that even worse. And we don't checkpoint the relation. So let's open the question and carry on the discussing through the, yeah.
So I just posted in the chat the link to my PR, which has a bunch of questions against the KEP. I'm
Cool.
happy to keep the conversation going there. I had a chat with Jordan this morning just to get some history from him. And I will go through the KEP when I get a chance later today and respond to Vinay's comments and update it with, you know, the results of the conversation with Derek. But I would love to keep the conversation going on that. I'm really down to these 3 points. And I think I'm totally willing to be swayed, but I really need to understand them because I think that there's precedent that this will set, which worries me.
Yeah,
Thank
thanks.
you.
And, yeah, thank you.
Thanks.
Thank you. And let's move the topic on
Thank you,
that.
Don.
Welcome to next time, and we also can carry follow in discussing and at least report back to the community and what we decided, what's the we resolved, and what's it is the new open question. So let's move to next topic. Manu, do you want to talk about the dev flow?
Yeah, so to give some bit of a background before Nalin jumps in is like, we are working on enabling unprivileged builds inside a pod. So basically not giving any privileges to the pod, but still be able to perform builds. And this is done using Fuse overlay FS, which requires dev Fuse in a container. And while doing that, we ran into some issues, and Nalin can talk more, I guess. Nalin.
Greetings, everyone. So the main problems we ran into, well, in this case, was DevFuse not being available to the container, the unprivileged container, I should say. What's going on there is that DevFuse is not available. When we create a host path char dev volume mount to make it available from the node to the unprivileged container, we still can't access it because it's not added to the unprivileged container's device list that gets set in its device control group. This only happens for privileged containers. And even though the kernel some time ago switched to allowing unprivileged users outside of containers to create mount namespaces and mount things in DevFuse, we can't get around this with just the volume mount. It doesn't fit the pattern for device plugins, which expect a certain limited number of devices in DevFuse can just show up anywhere you want it to be. And we don't have a solution for this right now. So we went looking, and it turns out there is an open PR that changes the kubelet so that when a device on the node is added as a block device or a character device volume mount in an unprivileged container, the CRI request also adds that device node to the list of devices that we tell the runtime to expose to the container. And that ends up causing the runtime to add it to the device control group, which would be perfect for this case. But it's been open for about a year, and I haven't seen any traffic in it for a couple months. So I was hoping for some info or guidance.
If I remember correctly, maybe we talk about this one at the SIG Node, or maybe it's different in the different SIG meeting. Michelle from the, or maybe Saad from the storage, actually proposed some other way to support this one. So, so I don't remember the detail, and so that's why. Did we follow on that one? I haven't looked at this request yet, so.
Okay, well, I'm going to post the URL for the request in the chat log so folks can catch up with it. Looks like the proposed options were device plugins, controls, CSI drivers, and a local persistent volume. Now, I looked at device plugins, and I haven't done the research on CSI drivers and local PVs yet, but I don't believe that any of them results in adding the device node to the devices list that we pass over CRI. So I don't think they'll solve this problem for unprivileged containers.
But CSI driver, we have a notion about volume device. Of course, it was done for block devices, but maybe for Fuse it also might work. And in case of device plugins, we had a similar scenario with our Intel integrated GPU devices, where the device node is actually the same, but the amount of clients to it might be unlimited. So what we did kind of hack what device plugin just artificially creates amount of entities, like how many of shared device users can use it. So with device plugins, it's possible. It's not the nice thing, but at least workaround can be done.
Is there a third path possible here? I guess it's for Don and Derek and Tim. So like where we use something like PSP or SCC or OPA to have a list of allowed host devices that a pod can mount, and then we just allow it to the CRI directly without creating a device plugin for such use cases.
I'm not suggest to using device plugin actually here. I was more like when we talk about the host path and I thought we agree to move to using of the common API, which is the CSI, and from now on, so not like the in-tray and or hard-coded of the volume management what we did in the past. So that's the current what my first reaction here, but I understand maybe there's some different special cases, and the current the CSI driver didn't support, the API didn't include it as well, but we can discuss. So so we could figure out what we are missing in the CSI API, how to make that generic. And also, but in generic enough, but at the same time can support the particular use cases you proposed here. Or we can think about, do we need to have the third category to support this one? So far, based on Alexandra and even like the device plugin, we could do something. It's hacky, but I try to not reinvent a lot of wheels here and try to see what's the existing mechanism, what is missing. So then to understand the discrepancy between those APIs, and then we can say, do we need, instead like immediate jump into introduce new API or new plugins, right? So that's my first reaction. So have you tried to look at the CSI API yet?
I hadn't gotten to that one yet.
Okay.
From device plugins perspective, like one concept which is highly missing is ability to use like infinitive amount of particular devices.
Yes, that's the initially when we proposed the device plugin, and unfortunately, until today, device plugin kind of a little bit specific to the GPU, and maybe this is the chance we make that more generic. Start support a second case. So I'm not proposed to really using or not using, but at least we need to understand what's the discrepancy here, and then. Yeah.
Don, regarding the GPU, it was also, we have a similar scenario. It was a bit hidden by NVIDIA in web hooks. So practically what happens is what, like for NVIDIA, you're exposing like two devices, like the card itself plus the controlling interface. And this controlling device was injected later. So that's why it was not so visible there.
Yes.
So I was trying to catch up with Manuel a little bit in the background here because I was curious what was bringing this to the top of attention, and maybe there are use cases that people are trying to meet that we're not appreciating. Manuel, do you want to give some detail on like what the use case is that this particular group is exploring?
Yeah, primarily, this is for doing unprivileged builds inside pod. So without being root, and using DevFuse and Fuse overlay FS, we can do that. So the first step is how do we get DevFuse exposed in a build pod without being privileged. Nalin, do you want to add some more details or?
Sure. Currently, we're using privileged pods with the kernel-based overlay file system. Fuse lets us do that for unprivileged users outside of pods. In the broader sense, what we're using these for is to do the copy on write layering for container image builds, so that we can extract the differences more efficiently than much slower methods that we have available to us, but which are kind of expensive in terms of time and resources.
So when I read the issue kind of just discusses, like, because a container runtime let me do this, Kubernetes must do the same type of level of discussion. What I'm wondering is if we can maybe get a more formal design authored on why Kubernetes should do this and what use case it fulfills, sure. And if we can scope it, I guess. And you know, at Red Hat, I know we do obviously container image builds in Kubernetes, and I know other communities are doing similar. And so getting something written around that use case is, I think, probably very clarifying for everybody when understanding why the request was coming.
Sure, yeah, we just saw this open issue and we wanted to see if there were any blockers around that, but we can create a new issue or an announcement, I guess.
Yeah, please. And yeah, I agree with the Derek. And clearly write down of the use cases, and then we can start from the use cases and to talk about and exam of the current solution. And then we are open to any suggestion. But we need to think about it. There's not just, we also have to examine why existing of the solution is not support these cases, use cases. Yeah.
Yep. Sounds good. Yeah, Naren and I will work on it. And
cool. Thank you, and looking forward. And you write down those use cases and come back. We can talk about more. So let's talk about another one, and our limit. And Manu, you are still on this one. Our limit.
Yeah. So again, like we linked to an older issue which has been open forever, but really this came up in the context of AI and ML workloads. Zvanko, are you on the call?
Yes, I am. Can you hear me?
Yes, you can. You want to talk about it?
Sure. Yeah. So it's sitting there like for 2015, and the use cases we have to set our limits per container is mostly from AI, ML, and HPC workloads, where we need to set unlimited memlock, specific stack size. Another use case comes from RDMA, where we need also memlock unlimited and other kernel bypass technologies provided by other vendors. And currently the situation is that we are enabling those limits globally per runtime. So for example, for CRI-O, we are creating a drop-in file for systemd and having memlock, stack size, and other variables unlimited. But we don't have to have those for all containers. We just want it for specific containers. The other thing is we can run a privileged container, which is not, which we don't want to use. We want to have all those settings per user in a container. And I wanted to ask the group how we can get forward on this issue of our limits in Kubernetes.
So to my knowledge, it's been there since 2015 because nothing has changed since 2015 on like a primitive we could use. Mm-hmm. And so I guess as Svanko, is there something that we might be missing? I see Don's original comment, I think still holds true from 2015, which is we don't really have a good knob to do this effectively, and the one that was used by Docker in the past wasn't really considered appropriate.
But Derek, we nowadays we have a seccomp profiles pattern where runtime can define like certain profile, and when the user can specify like I want to be this particular profile. So something similar can be here. Like I want limit profile like this, and on the runtime side, it will be just expanded to set of parameters for injected for container spec.
Yeah, so that's an area where we might have evolved since 2015 when I asked, like, is there a change that we should view collectively? Maybe that's one, but like just straight mapping the support that was in Docker to Kubernetes doesn't seem like the right outcome. And so do you agree with that, Svanko, or is there some other, is there a set of things you wanted to put together on this? Or is the process limitation sufficient?
I'm just thinking. Yeah, I'm just curious how we are going to specify this per pod and not for the complete node or for the complete runtime.
I mean, is it at the granularity of a pod, or are there bandings? And like, is this a place where a runtime class could be pursued or something like that in the background?
I'm just curious if we are allowing all pods to have locked memory, if pods could, you know, lock too much memory and starve other pods. If they have unlimited, let's say somebody sets unlimited core, unlimited memlock, unlimited stack size, if memory can be exceeded for other pods, if we are setting it globally for the complete node. They're like in our DMake use case, we have like two use cases. One is dedicated, where we have only one user and one workload running, and the other one would be multi-tenancy, where we have a couple of, I don't know, several tens of hundreds or containers running using RDMA with AIML workloads. And if we are setting this globally for all pods, if this could somehow break the node.
Yeah, I don't have a clear answer on that. I'm curious if others on the call have explored any other workarounds that we might want to raise. But I think, Svanko, we would have to sit down and think about that carefully.
Mm-hmm. Okay. Thanks.
Derek, actually, I want to ask you. So there's a while back, there's the unlimited SIG group very actively, at least relatively actively in the upstream kernel. Do you follow that one? Do you know what's the status? I forgot to follow last 2 years. And
I don't know the status, which is why I was wondering if there was a very real chance that someone like Svanko or Manal would have helped educate me on something that may have changed that I wasn't aware that had changed. So
okay.
I think that'd be useful to follow up. I guess, Svanko, are you able to follow up on that?
Yeah, I can follow up on that.
Or maybe even Nolan.
So,
you have good insight on this. If you're still on the call, you'd want to say if you were aware of anything happening there, but I don't know offhand.
I do think about the leaded, and the moment the 5 years ago, almost 5 years ago, if I remember earlier, people say I made some comment. If I recall that correctly, because people ask for to use in the Docker and container back then Docker's feature, unlimited feature, and that's process-based. We already agree, and that's very easy. It's not that user-friendly. So, but at that time, I remember there's the unlimited C group is discussing, and so that's why we hope to, if we there's the make progress, then we could enable that at the container level, at like the pod level. So we can utilize from the Kubernetes perspective. That's much easier to apply. And if that not make progress, and we need to understand why that's so complicated, and I can see some the complexity there, but do we want to understand what it is? So then we maybe not think about it from other way to do something, or maybe we can help the community, I mean the upstream kernel, to push down some requirement from user space. I think about the C group is so successful in the past. It is just because a lot of use cases push down the requirement, push down from the user space to the kernel. So that's why a second version of the C group is so successful, especially memory management. So we are in the unique of the space to send out those kernel folks and expertise and what's the use cases that user care about. I just want to share here and to see what we can do here, because the unlimited things actually has been raised many times.
Yeah, we can follow up on that for sure and see where the kernel is at, and we'll come back. So meanwhile, I was wondering like if a more limited use case with caveats can be enabled. Like, yes, all the processes don't get the limits, but in most cases, if your main container process, if we can apply limits to the main container process, that may be enough to alleviate the issues that Zwonko is running into.
Sure. Okay. Thanks. So let's move next one, sidecar container. And radio, you want to talk? Yeah.
Yeah, hello. So I wanted to ask, or maybe a quick update for Derek that wasn't here the last time. The last time I asked about this PR that I created to change the, with what we talked in the other signal meeting. So basically switch the sidecar cap to provisional state and mention that it depends on the kubelet traceable shutdown. That is still in the works. And I wanted to ask if there was any concerns with this PR that has not been merged, or just yeah, a friendly ping. Or...
Yeah, so appreciate the ping, and like you know that I wasn't here last week, and then the holiday weekend has still have me catching up. But I have your PR open now,
okay.
This afternoon.
Okay, I didn't know about it. Sorry. Cool. So if I understand correctly, this PRs, if it's fine, will be merged, and then I'll do another following PRs with the callouts that we discussed. Does it make sense?
Yeah, that sounds perfect.
Right. Thank you very much. That's all for me.
We already ran out of time. Thanks everyone. And Alexa, Alex, and I believe you just want to talk about the repository.
Yes, our question related to repository, but Swati will talk. Swati?
Yes, thanks, Alexei. So we presented topology-aware scheduling in SIG scheduling, and the scheduler plugin itself was approved to be placed in the scheduler repo itself, but we were hoping to get an opinion and get basically approval from the SIG node to have the topology exporter daemon, which is responsible for exposing the topology as part of the Kubernetes SIG. So just wanted to get opinion from Derek and Don, you.
Yeah, so Swati, I sent you some feedback privately on a Red Hat list, and I also did review on the two KEPs in question.
Sure.
And for some clarifying questions, like the one was, it wasn't clear if there was work happening in another CNCF domain that this was bringing in, or if it was net new work in the SIG. So some of those questions, I think you maybe even just answered there.
Sure.
And so if you can kind of update on that, that'd be great. And then my my understanding for the next discussion is basically there's a request that says, would SIG Node want to sponsor a sub-project to export topology information to the scheduler? And it sounds like you're saying the scheduler would support a built-in plugin that could read that information. My ask on the KEP was, why do we need to have more than one node fleecing agent in the community? And could we do this as a enhancement to node feature discovery or evaluate it in that context? And so maybe if you can look at that feedback and reach out to the sub-project maintainers there to see what their perspective is, that would be good going into our next discussion.
Sure. Yeah, I think the reason we didn't go ahead with the node feature discovery approach was because it populates the node information in the form of labels, and that wasn't something we were trying to do. We were trying to create CRDs here based on the resource topology. So that was the initial reason, but we can definitely think about it a bit more and see if NFD is the right fit.
Yeah, so I know we're over time, but the last parting concern I have would be that where we could centralize, in the case of NFD, like node labeling to like a core authority, rather than giving highly privileged credentials out to many different things, that was a desirable trait. And so I know the NFD community had to tackle that. And so it felt like that same problem would come up in this proposed project. And so if we can just talk through that so that we don't repeat the same iterative patterns, that would be good. And I know many folks on this call were involved in NFD, and so they'd be happy to share their experience.
Cool. Thanks, Derek. Thanks for the feedback and the review. We'll have a look and we'll try to address those questions.
So we really ran out of time. The people can leave, and also like but we have one more topic to talk about the hash. Do you want to talk about the federal image for the node testing, or you want to just simply update the status?
Yeah, no, I just wanted to know if we should, if you remember, we were talking about using Fedora, custom Fedora images, right? So, and the Fedora core OS right now is not possible to use because it requires reboots while you provision it to enable SIG v2. It's not enough just simply to provide cloud init file to it while system comes up. So we are trying to get a simple Fedora image to use for node testing, but it turns out Fedora image is not officially available. So we were wondering if there is a stepgap or an intermediate solution where we can host a Fedora 32 image for our node tests and then use it. So just wanted to know what you think about that.
I don't think about so there's the people. I think this is kind of a mix of the access, right? So to a project, and also mix about the CNCF binning, all those kind of things. So if you don't mind, can we have like a follow-up meeting, and then we can report back to the SIG Node here and see what's status? But it's harder for us to have this meeting here, and also people actually in charge of that account also is not here. So yeah.
So, do you want me to schedule a meeting, or how would you?
So how about you schedule a meeting with me, and I'd involve the parties here, and then you just add involved party from your side. I'd involve party from my side, and then we can come back later. So let's drive this offline, separate meeting. Is that okay? Get everyone in the.
I will reply. I will continue. I'll drop you an email with the same thread that we are having, me and Mrinal, and then we can talk over there about suitable time.
Okay. Yeah. Thanks. And Yash, I know you have a topic, but we ran out of the time. And can we follow up next week?
Yeah, sure, no problem.
And you also can send the formal cap, or maybe the file issue before make the request or something, and so we can follow.
Yeah, sure. Before the next meeting, I will issue the enhancement proposal in the repo.
Okay. So the last one, it is, I think, ask for approval, and I'm going to take a look, and I'm on that one. Okay. Just, I think the Alex will ask approval, and I will take a look at that one. Thank you, everyone, and have a great weekend. Week, sorry. Bye bye.
Yes, weekend. Right.
I'm looking forward to weekend. Yeah.